I want to welcome you to the Dallas Independent School District's STEM Environmental Education Center virtual field trip. I want to say a very special welcome to Stephen C. Foster from Dallas ISD this morning. Teachers, if you're watching, you have not signed up, please do so. Go to www.tiny.cc/6-8 registration and sign up, please. We appreciate it. The program this morning will be energy, resources, and transformations. During this virtual field trip, students will discover that some of Earth's energy resources are available on a nearly perpetual basis. Others can be renewed over a relatively short period of time, and some energy resources, once depleted, are essentially non-renewable. Mr. Dominguez will tell you about nuclear and solar resources. Mr. Ramirez will talk about the wind. Mrs. Ram will discuss hydropower. Coal, oil, and natural gas, aka fossil fuels, will be discussed by Mr. Monroe. You cannot ask us a verbal question, but you can go to www.tiny.cc/question-answer and send in a question. I'll do my best to answer them during the program. If not, I will send the answer to your teacher and they can share the answers with you about your question. We'd appreciate you sending us questions. Now I'm going to stop sharing my screen, and Mr. Dominguez is going to tell you about nuclear and solar power.
Hey guys, in this portion of your virtual field trip, we are going to be talking about solar energy and nuclear energy. And it's a beautiful day, so I wanted to take you guys on a walk. I'm going to go feed one of our redfoot tortoises some papaya. And I guess you could say that Teddy, his name's Teddy by the way, is solar powered. He's a cold-blooded creature that requires the sun's heat in order to maintain all the bodily functions he needs to survive. So we're going to go take a quick walk to go feed him. But today we're going to be talking about some of the advantages and disadvantages of those two forms of, two sources of energy. So after I feed Teddy, we'll get started with our presentation. Where are you, Teddy? There he is. Hey, Teddy. You hungry, bud? Let me kind of make my way to him, and he loves papaya, guys. It's one of his favorite foods. Here you go, Teddy. You hungry, bud? Yeah, he's pretty hungry. All right, guys, so let's go back inside and talk about solar energy and nuclear energy. Hey guys, I'm out here with my model son, and I wanted to start off by talking about solar power first because it's an incredibly attractive source of energy. It's something that if we invest our money and our minds into, may solve a lot of the issues we have with our current addiction to fossil fuels. And unfortunately, unlike the sun, fossil fuels have shown and are continuing to show that they are incredibly harmful to the health of our planet. So why is solar energy such an attractive form of energy? Well, it's because it's a clean form of energy. So the process that is going on here inside the sun is called fusion. And fusion is when two atoms fuse together, they combine to form a heavier atom. So for example, two hydrogen atoms come together to form a helium atom, and that process releases a bunch of radiation, a bunch of energy that we feel here on Earth. I actually feel it right now. It's pretty sunny. It's pretty hot. And that form of energy doesn't release any toxic byproducts. There's no leftovers that are going to be toxic and last us thousands and thousands of years. So there is no cleanup that we have to worry about here. This is a clean source of energy, and that is one of the biggest advantages, in my opinion, of solar energy. Now, let's talk about one drawback. Well, we don't always have access to the sun's full potential. a cloudy day or a rainy day limits the amount of light energy that gets here to our Earth. Now, why is that a problem? Well, even though you can still feel the heat on a rainy day, you can still see the sun every now and then on a cloudy day, on a rainy day. The solar panels that we use to harness the sun's energy um, are not going to be working at their full efficiency when that occurs. And that's another drawback. Right now, the technology that we use that we use to harness solar energy uh, isn't quite evolved to the state that would fulfill all of our energy needs. So, and it's expensive. Not everybody has access. Not everybody has access to the solar panels that make use of the sun's energy. So that is a huge drawback. Not having access to the energy, or not having access to use this wonderful source of energy. So even though this is a limitless source of energy that's going to last us, well, I guess I shouldn't say limitless, because the sun does have uh, an expiration date. It's only going to last us a few billion years. Um, but I'll take a few billion years of energy over the toxic waste that is created by fossil fuels and other forms of energy. Um, so let's talk about nuclear energy next, because even though nuclear energy and the process that makes nuclear energy possible is very similar to what's going on here in the sun, it is very different in terms of the byproducts that you get from fission, not fusion, fission. So let's get to talking about nuclear energy next. All right, guys. So what makes nuclear energy possible? Well, it's fission. And fission and fusion are similar because they both use atomic particles to create energy. However, fission splits a larger atom into two or more smaller ones, and fusion, like I've already stated, fuses two atoms together, and that process also creates energy. However, we run into a few problems when we are working with fission, and it has to do with the fuel that is used. So fission uses uranium and plutonium, and those are radioactive materials that last a very long time and are toxic. However, the advantages of fission and fusion is that they create vast amounts of energy, more than fossil fuels. Before I let you guys go today, here are some more benefits of solar energy. It reduces air pollution, it reduces water usage, it improves human health, and it helps fight climate change. And that all has to do with us using less fossil fuels and using this alternative source of energy. However, like we stated earlier in the video, solar energy hasn't been developed to its full potential yet. And although we do have nuclear energy available to us, we have harnessed atomic power. The fuel that is used in fission, such as uranium and plutonium, are radioactive and continue to be radioactive after they've been used, and they are harmful to our environment and to our health. But it is a great source of energy. So I hope you guys have a discussion about these two alternative sources of energy, and I will see you guys next time for your next virtual field trip.
Thank you. We do have a question. Just how reliable has nuclear energy been? It has roughly supplied a fifth of Americans' power each year since 1955. And many years ago, I was flying around the South China Sea in a helicopter, and we landed on the aircraft carrier Enterprise. It was a nuclear powered carrier, the only one in the Navy fleet. I was a little bit reluctant to land on that nuclear power because we didn't know very much about nuclear power at that time. And now, after the nuclear expression, we're going to have Mr. Maris tell us about wind.
Hello, my name is Ms. Ramirez, and in this segment, we're going to be learning about wind energy. So I'm going to go ahead and share my screen with you guys, and we'll get started. So let me get that screen share going. And there's a couple of essential questions that I want you guys to be thinking about as we go through the presentation. The first is you should be able to explain 2 advantages of using wind energy. The second is you should be able to explain 2 disadvantages of using wind energy. So keep those 2 questions in mind as we go through the presentation. I'm going to show you a quick little video though of, this is called the Strand Beast. It's a piece of kinetic artwork by a Dutch artist named Theo Jansen. And we're going to show a little video and how that relates to wind energy. So let me go to our next slide and hopefully our video will play. So this video is going to be some examples of wind and also how wind is used. So kind of an introduction to wind. So these are my 2 dogs. Yesterday, they were enjoying the nice windy day at the Environmental Center. The trees were rustling, the grasses were moving, and the leaves were just falling and drifting in the wind. So yesterday was a very windy day, and wind is formed by the uneven heating of air masses by the sun. And wind is a renewable resource. What that means is that renewable resources can be replaced at about the same rate at which they are used. So again, wind is a renewable resource. And wind is actually a type of renewable resource that is actually powered by the sun. So there's other renewable energy resources that are powered by the sun. You'll learn about those later, such as hydroelectric power or biomass. So wind would be an example of a renewable energy that is related and powered by the sun. And again, wind is just moving air that's caused by differences in air pressure within our atmosphere. So the uneven heating of the earth by the sun is what is creating wind. Here's an example of a windmill that we have at the Environmental Center. It actually pumps water from underground into some of our ponds. Here's an example of that little art. This is one that you can buy and create by yourself. It's a little kinetic wind sculpture. So much of the energy that we get from natural resources actually comes from the conversion of potential energy into kinetic energy. So we're using that wind to turn those little propellers, and it's creating that kinetic energy. We're changing it into kinetic energy. So it is important to note that energy is not created or destroyed. It's simply being changed into another energy form. But if you ever get a chance, feel free to Google the Strand Beast by Theo Jansen. He has some very interesting forms of kinetic sculptures that are wind powered. So again, we can harness the energy of the wind to do some marvelous things. So let's look at some other examples of how we can use that wind energy. So the most common way is by the use of wind turbines. So I know here in Dallas, you probably don't see a lot of this, but if you go out further into the country or into the panhandle, you'll probably see tons of wind turbines. So the way these wind turbines work is the wind actually turns these propellers, and those propellers are kind of like blades, and they will rotate around a rotor, and that will actually spin a generator, which creates electricity. So that's the simplest form. And there's different kinds of these wind turbines. So you can have land-based turbines like you might see in the panhandle. You might have some offshore turbines like you see here. And these offshore turbines that are in the ocean, they are massive. So they can be as tall as the Statue of Liberty, and they can actually capture those powerful ocean winds. So I thought that was pretty neat. And then of course you can also have what are called distributed wind turbines. And those are going to be your smaller turbines. So for example, the fire department down the road for me in Payne Springs actually has a smaller scale wind turbine that they use to power their facility. So they come in different sizes and ranges depending upon their use. Now let's talk about some of those advantages and disadvantages of using wind energy. So let's start with the advantages. So obviously it's a renewable energy source, so it's going to be a form of clean energy. The wind emits 0 emissions into the atmosphere, so it is a clean alternative to using those fossil fuels. And again, we know that those fossil fuels release a lot of those dangerous CO2 and also other pollutants into the environment. So with wind energy, we don't really have that problem. With wind energy, less space is often needed for a single power station. And so oftentimes farmers will actually get a subsidy. They will lease out their land for the government or whoever's contracting these turbines to put those turbines on their farm or their property, so they get money out of it as well. And the farmer can still utilize that land for farming or livestock. Again, as we mentioned earlier, it is a renewable resource, so it's kind of like a limitless supply of free power. And most often these wind turbines are going to be found in those remote locations. So that's how come we don't really see these around here in Dallas, but the further out you go, you're probably going to see them. Now, some of the disadvantages, can you think of any? So there are some disadvantages to using the wind energy. The most obvious is it's not really reliable. So some days might be super windy, and then some days might not be that windy. So the main issue with the wind turbines is the reliability. So wind strength can't be controlled, and in some areas, it's just not a viable source of power. The second is it does have a lower electrical output. So wind power generates significantly less electricity than fossil fuels do. So it's still not as efficient as using those fossil fuels. They are also super expensive to construct and to maintain. So they can be very costly to erect just one of those wind turbines. And then, for example, when I was going up to Lubbock during spring break, my parents are from Lubbock and Friona in the Panhandle. There are hundreds of wind turbines. Well, as we were driving up there, we were seeing lots of signs on the highway from people that were saying, you know, say no to wind energy. And apparently the reason that they didn't like the idea of having wind turbines in the area was because they thought it was going to fragment the habitat, the wildlife habitat, and it was going to be bad for their hunting season. So it was going to hurt the wildlife in the area. They didn't want the land fragmented like that. And then, and you can see in this little image, there are some bird deaths that do occur from those wind turbines. And then the last one is noise pollution. So they're not like super loud, but the closer you are, people have reported hearing like a hum, almost like a low refrigerator hum that's kind of constant. And then some people think that that might also interfere with wildlife, and wildlife might not want to go around those areas. So there are some advantages and disadvantages to using wind energy. And this last little slide is just a diagram that shows the primary energy consumption by energy source within the US. So if you take a moment to look at the energy diagram, you can see that mostly in the US, we're using petroleum and natural gas. So again, we're using those fossil fuels. Of the 11%, and again, this was from 2019, of the total usage, about 11% is renewable energy. And you can see that wind power actually has the largest segment, followed by hydroelectric power. And my challenge question for you guys is just a quick little research. See if you guys can Google or research why are wind farms more heavily located in the central US? So take a look at this map. Notice that Texas has a lot of wind farms, as do these central US states. And then see if you can Google what is the closest wind farm to you. So I know I often go to Abbott a lot, and from a farm over there, we can typically see the Hubbard Wind Farm #1. And a lot of people don't like it because at night you can see like hundreds of red glowing lights from the wind turbine. So they have to be lit up so that airplanes and other aircraft know that they're there. So I know a lot of people in Abbott did not like the Hubbard Wind Farm because of the light pollution. So the lights coming off it at night. So part of the lure of going to the country was it's nice and dark, but now at night, all you see are these red lights all year round. And also people were complaining about that weird noise, that low hum, and just it was kind of unsightly. So there are some pros and cons to having that wind energy. So just something to think about. So I'm going to stop my screen share, and that's all I have for you guys today on wind energy. We're going to give it back to Dr. Gorman to answer any questions.
Thank you, Ms. Harris. And a question came in: how fast does the wind have to blow to turn a wind turbine? A typical modern turbine will start to generate electricity when wind speeds reach 6 to 9 miles per hour. Today, guys, the wind is blowing around gusting up to about 20. So we'd have no problem turning one today. This 6 to 9 miles per hour is known as the cut-in speed. Turbines will shut down if the wind is blowing too hard, roughly 55 miles an hour, to prevent equipment damage. Now on our windmill out here, if it's going to get above 35 miles per hour, we shut it down and wait till the wind quits blowing, but we don't want to tear our windmill up. And thank you again, Ms. Ramirez, telling us all about wind and hydropower is now going to be discussed by Ms. Schramm.
Hey friends, good morning, it's Ms. Schramm, and we are talking all about hydropower. So let me get this going. Doo-doo-doo. Okay, here we go. Hydropower. So we are talking about water. So at the end of my little section, you'll be able to research and discuss the advantages and disadvantages of using hydropower. All right, so what on earth is hydropower? So hydropower is just harnessing the energy from moving water and turning it into electricity. So you can see the photo here is a river, and they have a dam blocking the river and controlling the water flow and collecting the energy inside. So how does hydropower work? Well, water flows from a higher elevation to a lower elevation due to gravity. We know that. And so, like I said before, the dam blocks the water and controls how much goes through at a time. So underneath, or like inside the power plant, hydropower plants use turbines and generators to convert this motion into electricity. So just like you learned from Ms. Ramirez, when the wind was blowing on those like paddles or the blades, it's similarly with the turbines used in hydropower, but instead of air hitting those blades and turning the gears in the turbine, it's water flowing and turning those gears. So let's keep going. So how does a dam work? So here's the inside, and we've got the water, like I said, at the higher elevation, flows through the dam. Then it turns those things into turbines, the little blades or the little paddles, turns those around as it goes. Then that is turned into electricity in the generator. Then it goes to a transformer, and then it's distributed to you. So there we go. All right, and we've been using hydroelectric power in the United States for over 100 years. And of course, you can imagine with technology changes and all that, it looks a lot different. So on the left is a water mill that's kind of like a little more old-fashioned. And like I said, that has to be like along the side of a river because it needs to be naturally flowing water, right? So we're from a higher elevation to a lower elevation. So it's kind of limited on where you could place water mills like that. And then on the right is obviously a more modern constructed dam. All right, so we got pros and cons. With all of these energy sources, we have pros and cons, of course. So the pro is that it's renewable energy, just like solar energy and just like wind energy. Water is always going to be moving thanks to our water cycle. Rivers are flowing, and we're not going to run out of energy from those rivers. It is more reliable than wind or solar energy. So like we discussed before, maybe it's a cloudy day, so you're not going to get that solar energy. Maybe the wind is still, so those wind turbines are not going to be turning. But you know, whatever the weather, the river is still going to flow. And so you can always kind of predict that you could get hydroelectric power. So it's more reliable than those other sources. And it has a flexible energy output. So when a river is dammed up, they can control how much water gets through, depending on what you need. There's more of a flexible output. And plus they can store energy more easily because it is a more reliable source. All right, so our cons, we got to have some negatives with it. It's a high cost of construction. So high cost of construction. As you can imagine, that takes a lot of work and a lot of effort and a lot of materials to build a dam, build a power plant. All those things are very expensive. And let's also see, it disrupts natural habitats. So if you're blocking off a river and controlling what goes through, that's going to disrupt the animals living upstream or downstream. There's going to be changes to the flow of the water. There's going to be changes to how much water or how many animals are in one area, who's getting through. Are fish going to be affected? Are they going to get hurt when they go through the thing? So it does disrupt natural habitats. And then there's limited number of sites to use for dams. So you can't dam up every river because, like I said at the beginning, we need the water to be flowing from a higher elevation to a lower elevation. So that's not always possible. And there's also a limited number of sites to use for dams because we already have dams constructed. So a lot of rivers that could be used for hydroelectric power plants are already dammed that are not like up to modern technology. So in order to get those working for us to collect the power, the engineers have to retrofit old dams to collect hydroelectric power. So I also wanted to show you an example of what engineers have done to help the fish. So of course, a lot of fish would be blocked off, right? But some migrating fish need to move upstream. So fish like salmon and sturgeon, they travel during the breeding season upriver, lay their eggs, then the babies go back downriver. So engineers have designed what they call fish ladders, like the one in this picture, to help fish keep migrating. So this actually helps a lot. So I was thinking, like when I first saw it, I was thinking they went down, but no, because these fish go upriver like salmon and sturgeon. So they kind of swim up in the currents and they kind of jump up each step of the ladder. And it also has, like, you can kind of see, it looks like little rapids, all those white areas, that's where the water is flowing most. So they jump up those areas, and then in the middle, it's kind of blocked off so that they have areas to rest, because obviously that's a long journey upstream. So they have places for the fishes to rest along the way. So I thought that's pretty cool. If you get a chance, I would look it up on YouTube and find a video so you can see the fish actually going up. But for copyright reasons, I cannot do that. And I don't have a personal video of it, but you should look it up. It's pretty cool. All right, then I have a picture of our most famous dam in the United States, the Hoover Dam. All right, so even though it's not one of the largest anymore, it's still famous and special. So it generates about 4 billion kilowatt hours of power each year, which is enough to power like 1.3 million people in Nevada, Arizona, and California. And like you saw with Ms. Ramirez, hydroelectric power only accounts for a small fraction of what we use in the United States. So hopefully more of those dams could get retrofitted to help us collect this power, because like I said, it's way more reliable than the other sources and it's renewable. So anything we could do to increase the amount we get from it would be best. Okay, so I have I don't have a water mill, but I have a little beach toy that is going to help us show how this works. So let me scoot you back so you can see my table. Ta-da. Okay, so this is my little water mill, just to kind of show you how it would work. So I have my little river here, aka the water in the beaker, and that's going to imitate the water moving from a higher elevation to a lower elevation. Then it's going to hit my little turbine, and you can see it's got those little paddles. So it's going to hit this curved paddle and push it down and turn it. Now, the part I am missing is I'm not collecting the energy, I'm just watching. So what I would need is another gear connected here to collect that energy. But this is just for show. So let's see. Open the floodgates, and there we go. That water is turning my little gear. All right, so that's just my little example. All right, that's all I have for you today. I hope you have a great rest of your day, and I can't wait to see you next time.
Thank you, Ms. Ram. And a student asked, how is electricity produced in hydropower? Hydroelectric power is produced with moving water. At hydropower plants, water flows through a pipe or penstock, then pushes against and turns blades in a turbine to spin a generator to produce electricity. Most U.S. hydropower facilities have dams and storage reservoirs. Okay, thank you very much for that program. And Mr. Monroe is going to tell us all about coal, oil, and natural gas, AKA fossil fuels.
Okay, good morning, students. My name is Mr. Monroe, and we're going to be looking into coal, oil, and natural gas. And of course, these forms of energy or fuel are considered to be fossil fuel. Now, I'm going to go way back in history. Well, I guess it's not too far back in history. When I was a little fellow, I remember growing up in a community where instead of burning wood, my great-grandparents burned coal in a stove that sat in the middle of the house. And I can remember that coal being shoveled into that coal-burning stove and really heating up a very large part of the house. Now, that kind of reflects back on my age. But as life progressed on and we moved into modern times, those coal-burning stoves were done away with. You know, as we live in our world today, things that are improving that make the environment a little better, those things are happening. And we have to let go of some of the things that are detrimental to our environment. Now, as I go through my presentation, there's a couple of things that I want you to really get a basic understanding of, okay? And those things are this. What processes led to the formation of fossil fuels? You know, later on, your teacher may ask you some questions about that. And then I want you to consider what advantages do we have when we're using fossil fuels, and what disadvantages does fossil fuels create? Well, I'm going to share my screen with you right now, and we'll get into the presentation. I want you to get your minds focused on those two or those things that I just mentioned to you, and let's get started. Fossil fuels, coal, oil, and natural gas, students. Now, the source of energy, the sun is a source of energy because it takes other sources of energy such as coal or solar to create electricity. Here we are looking at, and let me move my bar here. Currently, most electricity is generated through non-renewable energy sources. And what we mean by non-renewable is that coal, oil, and natural gas, it takes millions of years for that form of energy to be replenished. And so that's why they are categorized as non-renewable energy sources. Most electricity in the US is generated by coal burning power plants because it is the cheapest to use and produces large amounts of energy. And that's one of the advantages of using fossil fuels, because they have a concentration of large amounts of energy that can be released. The three types of fossil fuels are these: coal, oil, and natural gas. Fossil fuels are the most commonly used non-renewable resources that we use currently. The energy in fossil fuels originally came from the sun. And if you really think about it, that is true. You know, the sun provides energy to plants, and the plants use photosynthesis to help them grow using three main ingredients: light and heat energy from the sun, carbon dioxide, which is a gas that we exhale, and water. And then the byproduct that they kick out is something life on our planet needs, and that is oxygen. The ultimate source of fossil fuels is from the sun. Photosynthetic plants and marine algae lock the energy into organic matter. When we burn plants, coal, oil, or gas, we release the sun's trapped energy. Burning fossil fuels releases their stored energy. 3 problems with burning fossil fuels, and they are air pollution, water pollution, and soil pollution. Carbon dioxide is released when burning fossil fuels. Coal is an organic rock that originally came from dead swamp grass that compacted over millions of years. So the process of decomposition was a very important process that happened to those plants. The fossil fuel that remains, the remains of plants that lived and died around 100 to 400 million years ago, when parts of the earth were covered with huge swampy forests. And we can see when a tree died, it took a little time as it laid on the ground, and then eventually went through the process of breaking down, through the process of decomposition, and then it layered up and became sediment. And then over a long period of time, it became forms of coal. Coal is considered a non-renewable energy source because it takes millions of years to form. Now, I'm going to kind of talk a little bit about coal. The coal that we used in that stove, I remember it was lignite coal. There are 3 major types of coal: anthracite, lignite, and bituminous. Bituminous coal is considered to be a soft coal. Anthracite is considered to be a high quality coal. Now, anthracite is also used in the production of making certain metals like steel. Of the fossil fuels, natural gas reproduces the least amount or produces the least amount of pollution. Natural gas is a natural occurring hydrocarbon gas mixture consisting primarily of methane with other hydrocarbons, carbon dioxide, nitrogen, and hydrogen sulfide. Natural gas is an energy source often used for heating, cooking, and electricity generation. Petroleum oil is a non-renewable fossil fuel usually found underground in reservoirs located in sandstone or limestone. This fossil fuel is made from sea plants and animals that decomposed millions of years ago. The energy source used more than any other in the USA is oil. Gasoline is made from the fossil fuel oil. Oil and gas are formed from remains of marine plants, animals, and microorganisms that lived in seas millions of years ago. And that kind of explains why we have so many offshore drilling rigs that are drilling down to get that precious fluid that we call oil. Now, propane is a non-renewable fossil fuel also. That is a derivative of natural gas and petroleum. Now, currently we have an abundance of what we call fossil fuels. They provide a large amount of concentration of energy, and the low cost of transportation makes them pretty accessible. Now, there is also what we call the disadvantage, and the disadvantage is this, the major one. It pollutes the environment, and the other thing, it is non-renewable. In 210 years, we will not have coal reserves. In 42 years, we will not have oil. In 60 years, there will be no gas. So my generation, we don't really worry about that, but the coming generations, we have to do something about having energy resources for the coming generations. Now, I'm going to stop sharing my screen with you guys, and I'm going to turn it back over to Dr. Gorman in case some of you have some questions that you might want to ask him. So you guys have a good day.
Well, we do have a question. Student asked, how is fossil fuel produced? Fossil fuel power plants burn coal or oil to create heat, which is in turn used to generate steam, to drive turbines, which generate electricity. In 2017, fossil fuel generated 64.5% of electricity worldwide. These plants generate electricity reliably over long periods of time and are generally cheaper to build. That was some bad news, though. Mr. Monroe just gave us those figures about whenever some of this fuel won't be around anymore. That was kind of scary. So you guys, we got to really come up with some wind and hydropower and everything for you. And now I am going to share my screen. During this virtual field trip, students discovered that some of the Earth's energy resources are available on a nearly perpetual basis. Others can be renewed over a relatively short period of time. And some energy sources, once depleted, are essentially non-renewable. Mr. Dominguez talked about nuclear and solar resources. Ms. Ramirez covered wind. Ms. Schramm talked about hydropower. And Mr. Monroe talked about coal, oil, and natural gas, AKA fossil fuels. Thank you for joining us. Teachers, if you would, go to www.tiny.cc/6-8 feedback, fill out a very short form and send back to us. We would appreciate it. And you guys have a great rest of the day and rest of your life. Thank you for joining us.